questions you're posing there.
Thank you. All right, welcome everybody. Welcome in this amazing webinar, because this is it. This is it. The official Helm Chart of Airflow is out. So my name is Marc Lamberti. I'm the head of customer training at Astronomer, and my goal really is to make sure that you have everything you need to get started with Airflow in the best possible way. And today you are going to discover the official Helm Chart. But before diving into this topic, let me tell you a quick story, because I'm pretty sure that you have had experienced that as well. So I remember that back in the days, I wanted to deploy Airflow on Kubernetes. And so, as I'm definitely not a Kubernetes guy, and I don't want to be one because Kubernetes is truly a beast, I wanted to find the easiest way to deploy Airflow on Kubernetes. And obviously, Helm. So I was like this guy, trying to find the Helm chart to use and ready to deploy it on my Kubernetes cluster. So I was like super excited. Maybe not super excited, but really excited, because that will save me a ton of time. But here's the thing. After a few searches, I ended up like this guy, lost, completely lost. Why? I'm sure you had the same experience as me. You know, when you were looking for the Airflow chart and you got like 3 or 4 different charts and you don't know which one to use. I mean, think of it. You want to deploy Airflow in your production environment. You don't want to end up with a chart that is not officially supported, because you might end up with troubles. So I didn't know which one to choose. There was one on the official Helm chart repository. There was another one from Bitnami. There was another chart from Astronomer. And there was like the kind of official Helm chart, but it was in the Git repository in Airflow in a hidden folder. So I was like, okay, I'm gonna wait a little bit. But now this is over. Finally, this is over. Like 3 or 4 weeks ago, finally the official Helm chart of Airflow is out. And this is truly important for you, because now you can safely deploy Airflow in your production environment, as the official Helm chart of Airflow is supported both by the community and by the Airflow PMC members. So why it is important for you? First, because if Airflow gets updated, you are sure that your Helm chart will get updated as well. Okay, so that's the first thing. The second one is you can quickly experiment some new features of Airflow. For example, KEDA, which is not so new now, but still it is pretty new in the community. Or the Celery Kubernetes executor, if you like to mix Kubernetes and Celery. Also, if you want to make some tests locally, obviously the Helm chart is the way to go. And that's what you are going to discover. So at the end of this webinar, and this is my goal, you will have a fully functional Airflow development environment in local, running on Kubernetes, on a multi-node Kubernetes cluster, and Airflow will be deployed with the official Helm chart. So that is super important, because if you are using Airflow in production, you need a local development environment, and that's what you are going to get at the end of that webinar. And setting up a Kubernetes cluster in local is not easy. Deploying Airflow is not easy as well. But now you will truly understand how Airflow behaves in the context of Kubernetes. So that's why it is important to have this development environment. You will be able to make your own experiments without destroying your production environment. So you won't get fired thanks to that webinar. Now, I just would like to ask you a quick question before getting started. Can you just tell me in the chat, does anyone use another chart than the official Helm chart of Airflow? Please in the chat, just type me or something. I just want to know if anyone is using another chart than the official one. Please let me know quickly in the chat, just to have a better idea. Yeah, Bitnami, yeah. No, there is someone using the official Helm chart. Send. Okay, I guess a lot of people are using the Bitnami Helm Chart. Okay, so I hope that at the end of this webinar, you will use the official one. Let's get started. But before getting started, I just would like to tell you something here. I'm definitely not a Kubernetes guy. So if you have like issues that are truly related to Kubernetes, I'm not be able to help you. But don't worry, ask your questions. And if I'm not able to answer you, you will get the answers in the recap that we will send you. Okay, so that's just a quick warning here before getting started. So now let's jump into the code. Oh, actually, I forgot. I just would like to give you the different steps that you are going to discover. So first, how to create your local Kubernetes cluster, a multi-node Kubernetes cluster. Then you will see how to deploy Airflow with the official Helm chart in just a few seconds. Then you will see how to configure your Airflow Helm chart. Then last but not least, how to synchronize a private Git repository in order to fetch your Dags. Then maybe there will be a fifth step, but I can't talk about it yet. We will see. All right, now let's jump into your code editor. So the first step, in order to follow what I'm going to show you on your computer, you need some prerequisites. And the first one is to have Docker and Docker Compose installed on your computer. That's the two first tools you need to install. Then you will have to install kubectl as well. kubectl is the tool in order to interact with a Kubernetes cluster. That tool, we will use it extensively during the session. Next, you will have to install Helm, as we are going to use Helm in order to deploy the Helm chart. And finally, Kind. Kind is the tool that you are going to use in order to set up your own Kubernetes cluster locally. Maybe you know Minikube. It's just another tool in order to set up a Kubernetes cluster in local. I use Kind because back in the days I had to, Minikube. With Minikube, we had to set up virtual machines, which wasn't the case with Kind. So that's why I use Kind in this session, but feel free to use Minikube now, as you can use Docker as well. So basically with Kind, you are going to set up a Kubernetes cluster with Docker. So that's why you need Docker. So how can you create your own Kubernetes cluster? Well, the first step is to have this beautiful file, kind-cluster.yml, where in that file, you will get all the resources you need after the session, don't worry. So with that file, you define your cluster. So you have the kind cluster, the different nodes that you want. And if you carefully take a look, we have the control plane in order to interact with Kubernetes. And we have different worker nodes. So one worker node, two worker nodes, and the third worker node, okay? Now, in each worker node, we configure them and we specify a label. For example, you know that this node, the first one, the first worker node, has the label worker_1. Then the second one, worker_2, and the third one, worker_3. Why this might be useful for you? Because with the Kubernetes executor, you are able to define node affinity. So for example, in local, if you want to execute some tasks on a specific node, based on the name of that node, based on the label of that node, you can do that in local thanks to Kind, because here in the configuration settings of your cluster, you have specified the different labels. Okay, so that might be useful for that. And we have extra months, host path, and so on. I'm not going to talk about it yet. We will see that later in the session, but they are pretty important. So that's all you need. In order to set up a multi-node cluster, Kubernetes cluster, you just need that file. Now, in order to create the cluster, you have to type the following command, kind create cluster, then the name of your cluster. So let's call it Airflow-cluster, and the configuration file. So --config, and here it is kind-cluster.yml. So with that command, you are going to set up your Kubernetes cluster in local. Once you have done that, because I've already done it, takes a little bit of time, you will end up with your cluster, and you can verify if it works with the following command, kubectl cluster-info, if you want to get some information about your cluster. But also, you can take a look at the nodes of your cluster by typing kubectl get nodes -o wide. Okay, so with that command, you're able to see the different nodes of your Kubernetes cluster. And here you see the control plane, worker 1, worker 2, and worker 3. Keep in mind that those nodes are in fact Docker containers because that's how Kind setups Kubernetes clusters. That's what you will get. So at this point, you have successfully created a Kubernetes cluster. It is as simple as that with Kind. Now, what about deploying Airflow? Okay, it's important to focus here. So first, you need to create a namespace. In order to create a namespace, let's call it Airflow. So you type kubectl, create namespace, and Airflow. If you hit enter, you will create the namespace Airflow. And if you type kubectl get ns, you obtain all the namespaces you have, and you can see here Airflow. So this is the namespace in which you are going to deploy your Airflow instance. Once you have the Airflow namespace, you are ready to add the official repository of Airflow for the Helm chart. And so you type Helm, repo add, Apache-Airflow. Okay, so this is the official repository. https://airflow.apache.org. Okay, so by adding that repo, you will get the official Helm chart. And as you can see, it already exists. Once you have done that, you type Helm repo update. Always do that because you will get the latest version of your charts. This is truly important to do. If there is a new version of Airflow, make sure that you run Helm repo update to get the latest version of the Helm chart. And if you hit enter, you can see that the different Helm repositories are getting updated. So we have Apache Airflow, Astronomer, and Stable. And then you can look for the chart that you have right now by typing Helm search repo Airflow. If you hit enter, you get the different Helm charts corresponding to Airflow that you have right now. And you can see the official one with the chart version 1.0.0, the app version corresponding to the Airflow by default that will be deployed, 2.0.2, a description, and you can see that there are other charts as well, the one coming from Astronomer and the other one coming from the, how can I say that, the older stable chart of Airflow. Okay, so once you have the Helm chart, in order to deploy it, type Helm install, okay, Airflow, the name of the application, Apache-Airflow/Airflow, the namespace. Okay, so this is the repository. Then you have the namespace, Airflow, and as a best practice, I strongly advise you to put the option --debug, because you don't know in advance. If you execute that command, you won't see any logs. Okay, and for some reasons, Helm can get stuck, and it takes a bit of time to deploy Airflow, usually at least 5 minutes. So use the option debug so that you know what's going on during your deployment. And in my opinion, define a timeout like that, greater than the default value, which is 5 minutes. So for example, 10 minutes, okay, like that. With that very simple command, you deploy your Airflow instance in your Kubernetes cluster. I've already done that. Once your Airflow instance gets deployed, you type Helm ls-n Airflow, and you will see a release. And that release, that Helm release, corresponds to your Airflow instance. And this is truly important. Here, you know the name of your application, Airflow. Then the namespace in which your application is deployed, Airflow. But more importantly, you have the revision 1. Why it is important for you? Because with the revision, let's say you make a mistake in your Airflow instance, in your chart, and you want to go back at a previous configuration setting, at the previous version. Well, with Helm rollback and the revision, and the revision you want, you can quickly go back to a previous version of your Airflow instance. Okay, so again, if you made a mistake and you want to go back to a previous version where Airflow was stable, you can just type Helm rollback and the version you want, the revision you want. Okay, so that's why it is truly useful. Then you get the date at which your DAG has been deployed, and you have the status deployed. Truly important to check the status. So it's good to always execute that command before deploying a new version of your Airflow instance, just to check that you, in fact, don't have any error. That being said, once your Airflow instance is deployed, by default, the celery executor is used, which means if you take a look at the pods you have corresponding to your Airflow instance, by typing kubectl get pods -n Airflow, you can see all the pods that are deployed by default as Airflow uses the celery executor. So you have Flower, the Postgres method, the Postgres database, Redis, the scheduler, stasd, web server, and a worker. As you are going to see later, we are going to use the Kubernetes executor. Flower, Redis, and the worker will disappear. Okay, so you will end up with the scheduler, web server, and so on. But that's what you should get. Whenever you deploy Airflow for the first time with the Helm chart, you will get this. Okay. Now, one quick thing, if you want to check the logs of the web server, for example, or the scheduler, you can type kubectl. This is more related to Kubernetes, but still it is important. Type kubectl logs. Then, for example, the scheduler, like that. Take the pod, you type -n Airflow, hit enter. You have to define the containers because there are multiple containers running in the scheduler. As you can see here, you have the scheduler and the scheduler garbage collector. Okay, so that's why you can see two containers here. So here you specify -c and the scheduler, like that. Okay, if you hit enter, you can see the logs of your scheduler. That's how you can check the logs. All right. So now you have your Airflow instance deployed. It's time to take a look at the UI, right? I mean, you want to access the UI. You don't want to stay with the console, with the terminal. So for that, you just type kubectl, this command kubectl port -forward. You are going to forward a port. SVC for service, Airflow web server 8080. So that's the port you want to bind. -n, the namespace Airflow. And the context, or actually you don't need the context. Just hit enter, and then you have successfully forwarded the port 8080 to your machine. If you go to your web browser and try to access localhost colon 8080, you land on the beautiful page of Airflow. By default, the user is admin, hit enter, and you get the UI. So at this point, you have successfully deployed Airflow with the official Helm chart on a multi-node Kubernetes cluster locally. There is another step. So now you have done that. If you carefully take a look at the version here, this version is 2.0.2. So the question is, how can you upgrade your Airflow instance? How can you modify your Airflow instance that it is deployed in your Kubernetes cluster? Let's see how to do that. So if you go back to your code editor, let's open a new terminal here. And one thing that you have to know is that any Helm chart has a file called values.yml. So with that file, values.yml, you can configure your Airflow instance, or more specific, or more generally, your chart. So how can you export the values.yml file? Well, you type helm show values apache -airflow/airflow and values.yml, like that. Hit enter, wait a little bit, and if you open the file values.yml, you get the configuration file of Airflow. So that's how you can configure your Airflow instance with Helm. And as you can see, it is a pretty big file. So what can you do here? I'm not going to dive into each configuration setting, otherwise you are just going to fall asleep. But let me give you some important settings. So first you have the Airflow home, and the Airflow home is where Airflow is installed inside the different Docker containers, okay? So /opt/Airflow. Then you have the default Airflow repository corresponding to the Docker image of Airflow, where corresponding to the repository where the Docker image of Airflow is going to be put. Next, you have the default Airflow tag, so the version of Airflow you want, and you have Airflow version here. So don't be confused by those two names, those two configuration settings. The first one corresponds to the Docker image of Airflow that you want to pull. And the second one is used internally by the Helm chart in order to take some decisions. For example, if you specify a version before 2.0, you will execute automatically Airflow initdb. And if you use a version greater or equal to 2.0, you will execute Airflow db init. Okay, so that's kind of these kind of decisions are made thanks to that configuration setting. Okay. Then you have some images, basically all the tools that you need to, for example, have the server executor running, Flower, stasd, and so on. So if you want to change the images of the different components, you can do that here. Next, you have an ingress. Obviously, in production, you will have an ingress configured in order to access to the different paths of your Airflow user interface, and you will have a load balancer as well. Then you have Flower, the RBAC UI, the executor you want to use. By default, it is the server executor. You can define other executors as well. Then there is the env configuration setting, which is pretty useful because you can define the environment variables that you want. And those environment variables will be available across all of your Docker containers in your Airflow instance, basically. Same thing for the secrets. If you have some secrets, if you have some credentials that you want to hide, you can create secrets based on those credentials and store them and specify them here. Then you have additional information, extra secrets. The way you want to define your secrets is different. You have extra config maps, extra env. So if you are wondering what is the difference between extra env and env, basically with extra env, you can use templating. So for example, here, this will work inside extra env. Sorry, it's hard to say for me. Extra env, okay? So you can use this templating. You can template the values that you put in extra env. Whereas with env, you are not able to do that. That's the difference between the two. And as you can see by the to-do, this, I think, is going to be removed. Extra env from another way to extract some environment variables. So basically, as you are going to see in a minute, you can export some variables. Why it is important? Because as it's going to be your Airflow testing environment, your Airflow development environment, you want to create some variables, but you don't want to have to create those variables again and again. I mean, when you are going to delete your cluster and recreate it again, you will use your variables. Okay, if you redeploy your Airflow instance, you will use your variables, and you don't want to write them again and again. So in that case, defining a config map with your variables that you want to export and put it right there might be truly useful. Okay, it will save you a ton of time. Again, your goal is to have some connections, variables that you have defined and keep them whenever you update your Airflow instance. Then you have other configuration settings. There are really a lot of configuration settings in that file. You have the web server if you want to configure it, the scheduler. As you can see here, by default, there is only one replica. If you want to test how Airflow behaves with multiple schedulers, you just have to modify these value replicas. Same thing for the web server. Right below, you have the web server here. You can increase the number of web servers you have, you want to deploy. The default user is admin. It is defined right there. And some other services that you can configure, okay? So it is a really, really big file. Take a look at it, but that's all you need to know right now about it. And we are going to come back at it really often during that video, that session. So that being said, let's modify our Airflow instance. So the first step is to modify the Airflow version. So instead of having 2.0 here, we're going to use 2.1.0. That, and we change the version here as well. Okay, so now we know we want the version 2.1. Next, we are going to modify the executor, which is the Kubernetes executor. We want to use the Kubernetes executor. And we are going to add a config map as well, right there in extra env from. So let me look for that environment, extra env from, right there. You just remove this as well, define a config map, ref, so the reference to your config map, And here you can specify the name of your config map, which is airflow-variables. Okay, and you save the file. This config map is the following one right there, variables.yml. And as you can see, it is a config map, really simple, with the name airflow variables. Okay, so that's what you are referencing from values.yml. And you have data, then your environment variables that you want to export. In that case, you create a variable in Airflow with _var, with the key my S3 bucket and the name and the value my S3 name. Okay, that's what you are doing here. Once you have this config map and your file values.yml is ready, you are ready to upgrade your Airflow instance.
Hey, Mark.
In order, yeah, tell me.
I think you missed an R in your config map, Airflow variables.
Oh, sorry. Thank you very much, because I can do I can waste a lot of time for that. Thank you very much.
Of course.
Thank you very much. So yeah, so let's save the file and let's see if it works. And hopefully, I hope I didn't make any other mistake here. So first you have to apply, you have to upload that config map in your Kubernetes cluster. So you type kubectl apply -f and variables.yml. Okay, so by doing this, you upload your config map into your Kubernetes cluster, and then you type helm ls -n airflow to check the release. Now you have the version 1, the revision 1. So let's upgrade your Airflow instance. Type helm upgrade like that --install airflow apache -airflow, again same command as before, airflow -n airflow -f values.yml. Okay, this time you pass the configuration file that you want to use, which is values.yml, and --debug. Hit enter, and let's wait a little bit. Oops, I think I made a mistake somewhere. Okay, let me see. That's usually the good thing with. Okay, so it's in the extra and from right there. I need to put this like that. And let's update the Helm chart. Here we go. Oh no, that's the good thing with live coding. You always get bugs. Okay, so unknown field name. Yep, I think name should exist. Yeah, live demo are hard. Yeah, exactly. But now it works. Okay, so as you can see, you really have to take care of your indentations as well. So now Airflow is getting upgraded. In fact, you can take a look at your pods. So from another terminal, if you type kubectl get pods like that, you can see the other pods, and you can see that right now a new scheduler pod is getting triggered, is getting started, and the other pods corresponding, for example, to the cell executor that were used for the cell executor, like Redis, are getting terminated. Okay, so that will take a little bit of time. Meanwhile, do you have any question? If you have any question, please let me know.
A couple of questions in the chat, Mark. I think you can answer these right now.
Yeah.
If I am trying to add Python libraries, do I do this in this config, or should I do that later on?
Okay, that's really great, because you are going to see that in just a few seconds. Just after the deployment, you will see how to add your own providers, because I've seen that question so many often. So it's time to answer that question. So yeah, you are going to see that in just a few seconds.
I thought so. Hopefully that answers your question, Milan.
Okay, let's see the pods. You can take a look at the pods right now. So as you can see, pods are getting created. Yeah, that's the only step where it takes a bit of time, because the new Docker image, the new Docker image of Airflow is getting pulled. You can take a look at, for example, if you want to know at which step your Kubernetes pod is, you can take a look at that just by typing kubectl describe pods. And for example, you want to take a look at this, for example, the web server, okay, this web server here. you copy and paste it right there, the namespace Airflow, you hit enter, and you can see that right now the image Airflow 2.1 is getting pulled. So that's why it is taking a bit of time. I think my internet connection is not that good. Can we sync the Dags from a GitHub repository using the Helm chart? Yes, we can. And you are going to see that just after that Airflow gets deployed, hopefully in a few seconds, you are going to see that. Arjit, you will see how to do that. And not only for a GitHub repository, but from a private GitHub repository, because usually people are wondering how they can do that with a private GitHub repository. So you are going to see that. So let's see the pods. Okay, some of them are running. Still need to wait a little bit. Meanwhile, you can also check. Let's see, Helm. Oh, actually, it is deployed. Okay, my bad. I didn't see that. I got confused with the different terminals. So right now you can see that now Airflow 2.1 has been successfully deployed with the Helm chart. So let's verify if it works. First, you type helm ls-n Airflow to check the release, and now you see a new revision. The revision has been increased by 1. So again, this means your Helm chart of Airflow has been successfully deployed. And if you want to come back to the previous one, you just type helm rollback 1. Okay, let's see if it works. Hit Control-C. Let's do the port forwarding again. Let's go back to the web browser, refresh the page, type admin. And as you can see, right below, you have the version 2.1.0, as expected. And now, just a quick thing, if you click on admin and variables, you don't see anything. So where is the variable that you defined in the config map? One thing that you have to remember is that when you create a variable using environment variables, those variables, you can't see them from the UI, neither from the command line interface. But you can verify that it works just by opening a bash session to one of your containers, to one of your pods. So for example, let's list the pods, then type kubectl exec --stdin --tty, and let's use, for example, the web server, okay, but that will work with the scheduler too, and Airflow, the namespace Airflow, then /bin/bash. So that's how you can open a bash session in one of your pods. Hit enter, you are inside. Now if you type Python and type from airflow.models import variable, like that, and type variable.get the key of your variable, which is my s3 underscore buckets, you can see the value my s3 underscore name. And that's exactly what you are going to do in your code, in your DAG. Okay. So with the config map, now you are sure that every time you deploy a new Airflow version in your Kubernetes cluster, you won't lose your variables or your connections. You won't waste your time anymore. Great. Now it's time to answer the crucial question, how to add your own providers. Okay. That's a fairly interesting question. Well, let's imagine that you want to interact with great expectations from your DAG. How can you do that? The first step is to find the provider to install. Remember that with Airflow 2.0 now, you don't have all the tools you can interact with built inside the Airflow core. You have to install additional providers. For example, you want to interact with AWS, you will install the AWS provider and so on. So what about Great Expectations? Great Expectations is a data validation framework. I love it, but that's not the point here. Let's see how to install that provider. So the first step is to go to the Astronomer registry. And if you don't know that tool, trust me, it's not because I'm working at Astronomer, but truly this tool saves you a ton of time. As you know, Airflow has more than 700 different providers, different operators. And so with that tool, you can quickly find what you are looking for. So here, let's type Great Expectations. And you can see the provider Great Expectations. Click on it. Then you have the quick install command and the version. Copy that. Create a new file, requirements.txt. Okay. And paste the provider. So in that case, it is Airflow provider Great Expectations. Then always pin the version. This is a best practice. Don't forget to do that, which is 0.0.6. And save the file. All right. So you have your requirements file ready. But with the Bitmoney chart, there is a good chance that right now you are mounting that file in a volume. The problem with that approach is each time a new pod gets started, your requirements will be evaluated. So that means each time a new pod gets started, each time you, for example, execute a new task, okay, with the Kubernetes executor, you will install anything that you have in the requirements file. So that's not a good practice. I mean, it's not recommended in production, definitely not. So the better way is to, in fact, copy that requirements file in your Docker image. That Docker image is based on the official Airflow Docker image, and then use that Docker image to deploy your Airflow instance. Okay? So that you won't have to install each time you create a new task, each time a new container gets started, you won't install all the requirements you have. Okay? So how to do that? Really simple. You just create a new Docker file. Then in it, you type from the base image, which is Apache/Airflow, like that. You specify the version. Never use the latest tag. So .1.0 like that. And you copy requirements.txt in the image, and then you run pip install. Or actually, I forgot run here. So you type run pip install -or requirements.txt, like that. And that's it. Okay, so at this point, you have a new Docker image that will install anything that you have in requirements.txt, so your providers. Now it's time to build that Docker image. So you type docker build -t airflow-custom, for example, with the version 1.0.0. Hit enter, wait a little bit. Now the Docker image has been built. That's what you can see here. You are ready to use it. How can you load that Docker image into your Kubernetes cluster? Okay, because you have your Kubernetes cluster, but Kind is not aware of that new image, okay, the new Docker image that you have just created. So how can you load it? Well, with Kind, one thing you can do, and this is the easiest way to do that, is to type kind load docker-image, okay, and then airflow-custom, the version, which is 1.0.0, --name, airflow-cluster, the name of the cluster. This time, not the namespace, but the name of the cluster. Hit enter, and you just have to wait a little bit. I hope it won't be too long, but you have to wait a little bit until the image gets loaded to the different nodes that you have in your Kubernetes cluster. Okay, so that's how you can install your own providers. That's how you can add any Python modules that you want. You can do that by creating your own custom Docker image, put your providers in requirements.txt, specify the requirements file in your Docker image, and then use that Docker image as your Docker image to run Airflow in your Kubernetes cluster. By doing this, you won't install the same requirements again and again each time a new container gets started. Okay. Can you mount Postgres data to local disk? Yes, you can. I'm not gonna show this in the video, but you have some settings that you can use to configure your Postgres instance. But yeah, basically you can do that. To be honest, I'm not sure how to do it, but I know you can do it. I know you can do it, but I'm not sure how you can do this. But yes, you can definitely get the data from your, because Postgres here is used another image. Okay, as you can see right there, you see Postgres well, the Postgres Postgres image is built in by default, okay, with the official Helm chart of Airflow. But you can get the data that you want. But I'm not sure how to do that, so I'm not gonna say anything wrong here. I will let you know in the recap, but yes, you can do that. I'm pretty sure you can do. Okay, so now the Docker image is loaded. It's ready. You are ready to use it. So how to use that? Well, go to Dockerfile, actually values.yml, and here back to the version you want to use. Instead of 2.1, here you specify 1.0.0 and the repository, which is this time airflow-custom. And that's it. Upgrade your Airflow instance again. And this time it's going to be much faster because the Docker image exists locally inside the kind cluster. So let's wait a little bit. And you are going to see that the provider Great Expectations hopefully has been successfully installed. Okay, great. We can take a look at the pods. So again, kubectl get pods. You have your pods. Perfect. Let's verify Great Expectations. How can you do that? Type kubectl exec. Let's use, for example, the web server, but again, this will run with, this will work with the scheduler as well. And you type -n airflow --airflow info. So with that command, you are able to get some information about your Airflow instance and the providers that you have successfully installed. So hit enter. Let's wait a little bit. And as you can see, you get Airflow provider Great Expectations installed. So that's how you can install your own providers, your own Python modules. Okay, now the fourth step. How can you get your Dags? Because right now, I mean, if you take a look at the UI, that's great, but you don't have any Dags yet. If you type admin here, you don't have any Dags. So how can you get your Dags? Let me show you this. First, I have this repository, and this repository is private. That is important to notice that. So the first step, whenever you have a private repository, is to create your SSH key if you don't already have one. So you use SSH key again in order to get your private key. Once you have your private key and your public key, go to the settings of your repository, and in deploy keys, deploy a new key. Add deploy key, specify a name, the name that you want, and here you put your public key, okay? Your public key, not your private key, your public key. And don't select allow write access, you don't need to do that. Okay, so once you have done that, you will have something like this, corresponding to your public key. And back to the code editor, you need to configure your chart. For that, right below here, you have Git Sync. So with Git Sync is a sidecar container that will run in addition to your, for example, web server container. And this Git Sync is in charge of pulling your Dags from your repository at a given interval of time. By default, as specified here, it is every 60 seconds. So every 60 seconds, you will get your Dags pulled from your repository. So let's enable this. So here you set true, okay, to enable it. Then the repository, this is pretty important because we are going to use SSH to do that. So here you type, you go back to your repository, select it, click on code, SSH here, copy that link, go back to values, paste the link here and type SSH : / and important, type / here as well, okay? This is super important. If you don't use SSH here, it won't work. Then the branch is main. You can keep the other values by default. Subpath, there is no subpath, okay? That means your Dags are at the root path of your repository. And now, as you need to give your private key, you want to use a secret. Okay, so a secret in Kubernetes is an object in order to put anything that you want to hide. It's not really secure, but it's the way to do it. To do that, there is better way for that, obviously, in production. So let's create that secret. In order to create the secret, you just need to type kubectl, okay, in your terminal, type kubectl, create secret, then generic, the type of secret you want, airflow-ssh-git-secret, the name of the secret, --from-file, equals to SSH, or actually git SSH key, equals to where your private key is. In my case, it is /users/marklamberti /.ssh/id_ or SE or SA. Then -n Airflow. Okay, so by doing this, you are going to export your private key into a secret object in your Kubernetes cluster. Hit enter. Now your secret is created, as you can see here. You just need to copy that, the name of your secret, remove this SSH key secret, and paste the name of your secret here. Okay. And if you are wondering why this key is used, git SSH key, that's how you should do it, as specified here. Okay, so now you have your SSH, your secret ready. Again, you just need to save the file, values.yml, and you are ready to see if it works. So upgrade your Airflow instance again, hit enter. Let's wait a little bit. It's going to be pretty fast. Okay, let's see. You can always take a look at your pods. It's always good to do that. You can see the different pods that are getting triggered. And now, if you carefully take a look here, you don't have 2 containers only, but 3 containers. Why you have 3 containers for the scheduler? That's because of Git Sync. Okay. The scheduler in Airflow 2.0, only the scheduler parses your DAG files, as well as the workers, but let's keep things simple here. That means the web server doesn't need to access your DAG files. Okay, your DAGs are serialized in Airflow 2.0, and that's why here only Git Sync, and that's why here only the scheduler gets Git Sync running. Okay, so that's why now you have 3 containers and not 2 as before. Okay, let's see if it's been deployed. Perfect. We can take a look again at the pods. Okay, everything looks good. One thing you can do is to take a look at the logs of Git Sync. You know, if you made a mistake, it's good to know how to debug that. You just need to type kubectl logs, the scheduler, -c git sync, okay, for the container, -n airflow, and you get the logs of Git Sync. Okay, so if you made a mistake, it's always good to take a look at the logs of Git Sync. And as you can see, it works. So now, if we go back to the UI, let's go back to the UI and refresh the page. Admin. Oh, there is no Dags. But I'm not afraid of it, because that's perfectly normal. Why? Remember that by default, Airflow will fetch your Dags for new Dags in your folder Dags every 5 minutes. So that means at this point, if I want to get my Dag, I will have to wait at most 5 minutes. Okay, and you will see it from the UI. Okay, and once your Dag has been detected, then it will be parsed every 30 seconds by default for modifications. Okay, so but remember, if you don't see your Dags yet, that doesn't mean Git Sync doesn't work. It just means that Airflow is taking time for getting your new Dag files. Okay, so let's wait a little bit. Hopefully, at some points it will appear. If you have any question right now, please let me know. I see a lot of questions.
Ton of questions for you, Mark.
Wow. I'm gonna give a quick warning here. I'm not a Kubernetes guy, but I will do my best. Okay, let's see. Okay.
I think I can take Tushar's question while we're
sure.
Here. Yeah, so you can definitely use things like an EFS or an NFS to mount and share your different DAG directories. A lot of it will depend on what the requirements are for what you're looking to do. You know, one other thing you can do is actually just build the dependencies directly into the Docker image, right? The SQL files or something. Tons of ways to do that, Tushar. Nothing wrong with using EFS or NFS. We just want to understand your use case a little more to know what the recommendation is around that. And I'm going to drop my email in the chat here, so you can reach out to me directly if you would like some guidance there.
Luan, you are asking if other Kubernetes providers like EKS CTL will have a similar command to load used by canned. That's a good question. I think so, but I can't tell you because I really use only kind for deploying Kubernetes clusters in local. Also, can we add multiple GitHub repos in Git Sync? I don't think you can do that. I don't think that's something, Viraj, you tell me if I'm wrong, but I think you can't do it with Git Sync. You have to specify only one repo, but you can use different branches. Okay, that's the thing. If you have, for example, your dev environment, your staging environment, your prod environment, you can have different branches and so pull different Dags according to the environment you are. Okay, is the Git Sync in the Helm chart also pull plugins from the repository? I guess you are referring to plugins like custom operators or things like that. If you are wondering this, no, that's a different thing. I mean, you can do that, but the thing is, you will have your folder plugins in your folder Dags. Okay, that means if you want to add your plugins, you will have to put them in the folder where your where your Dags are. But you can use Git Sync for that if you want. Just in my opinion, use one file which is .airflow ignore in order to say that this folder, the folder plugins, doesn't contain any Dags, so no need to scan it. And then you might have another folder with the folder Dags and put your Dags in it. Okay, so you can use Git Sync for that, but just keep in mind, use Airflow ignore in order to avoid having Airflow scanning for things that are not Dags. Okay, so we get the DAG, we get Airflow, we get the DAG, my DAG as expected. So as you can see, now you are able to fetch your Dags from a private repository. If you click on it and turn on the toggle, then go to graph view, you will see your tasks getting executed. And in fact, as we are using the Kubernetes executor, you can type kubectl get pods-n airflow, and you see that for each task, you get a new pod. So that's the good thing by having your local development environment, is that you can truly understand how Airflow works, how Airflow behaves in the context of Kubernetes. And Kubernetes is truly difficult to configure. So that's why now you can do whatever you want without destroying your production environment and without getting fired, which is great, okay? So now you have a fully functional development environment and you can truly test everything you need. And now you know how the official Helm chart works. There is something that I didn't show you yet. If you click on the task and click on log, you are not able to access to your logs, which is a big issue, right? I mean, you want to access your logs. You will see how to do that in the email that we are going to send you. With the recap, you will see how to configure this. So I hope you enjoyed that webinar. It was truly, it was a truly a good moment with you. And now you are ready to use the official Helm chart and deploy Airflow in your Kubernetes cluster locally. So now you have a fully functional development environment. If you have any question right now, I'm gonna answer them. Otherwise, thank you everyone.
Awesome.
Okay.
So many good questions here.
Yep. Okay. Can I create a default? Well, Viraj, you tell me which question you want to create. Too many questions, actually. Actually,
We're testing the setup using Minikube. Do you have a Docker article on the implementation? What's going to be sent out to everyone in follow-up for Sligod?
For Minikube, if you want to use Minikube, right?
Mm-hmm.
I mean, all the parts for everything you've seen for deploying Airflow is truly similar, but for creating a Kubernetes cluster, obviously it will be different. I don't know how to do that with Minikube. Really, I used it when you had to set up a virtual machines, when you had to set up a virtual machine. So I truly don't know how it works now, but I guess it might be pretty similar if you want to use Minikube.
Yeah, I've used Minikube before. It's almost the same as what you did. Just the process of getting started with it is a little different, but I think the Minikube docs are pretty good on that. From the Airflow side, it's exactly the same. Cool. So, question around the external database. Do you have to use a K8 secret for the external database, or can you use something like Vault for that?
Sorry, can you repeat the question?
Yep, it's from an anonymous person, or I'd say their name. But it's
okay.
If you're trying to use an external database, can you use Vault to access that external database, or do you have to use a K8 secret? As far as I know, right now, you have to use a K8 secret for that Airflow backend database. You can use Vault for all of your other environment variables, but for the initial one, because it boots up with that, you have to use that.
Yeah, exactly. Okay, let's see.
Okay. So another question, Mark, I think generally, a few people have asked parts of this, but would you say that this is a production setup? Or would you say this is just a good way to kind of learn what you're doing?
No. This is really, I mean, for the requirements file, for example, yes, in my opinion, it's a good thing to do even in production. But otherwise, there are better way to get your secrets, for example. But this is more related to Kubernetes. But for example, you don't want to store your secrets in secret objects. Okay, you want to use Vault, for example, instead of a secret object like that. But otherwise, it's a good start. It's really a good start if you want to get started with Airflow running in Kubernetes and see how it works with the Kubernetes executor and have a fully functional development environment, because this is truly important. Usually in companies, you have multiple environments, but you need to have your local development environment to make your test. And this is a really good start. Okay, you have everything you need to make your own experiments. So yeah, I wouldn't say what you've seen is for production, but you can definitely dive into the file, into the values.yml file, and look for the options you need to configure it for your production environment. It's a really good start.
Yeah, it's much easier to build a production environment when you can test one locally, right?
Yeah, definitely. Yeah, definitely. I mean, there are so many things that you have to deal with when you use Kubernetes. Because I mean, Airflow is the thing, right? But there are still Kubernetes that you have to deal with, and so sometimes you get errors that are not because of Airflow, but because of Kubernetes and how you configured it. Okay, so I mean, definitely, if you want to run Airflow in production with Kubernetes, it's another story.
Awesome.
I've seen. Yeah, I just seen something, because that's important. I've seen something talking about the RAM problems. That's a good point. If you want to do what you have seen on your computer, usually you will have to increase your RAM. Okay, if you are on macOS, change your memory, increase it by at least 8 gigabytes, so that you're sure you will be able to run Airflow with Kubernetes. Otherwise, you might get some troubles. I know it happens. It happened for a lot of people, so that's why I'm saying this. Wow, so many questions.
So many questions. I don't know if we have time to get through all of these. Oh man.
Yeah. Hey. Well, we will keep your questions, and we will see which, I mean, we will answer them, most of them, maybe not all of them because there are so many questions, but we will answer some questions during the recap. Thank you, everyone. Again, it was a truly pleasure to be with you. I hope you enjoyed that session. And now you have a really good start to have your development environment. So thank you, everyone. Thank you, Viraj. Thank you, Jason. Thank you, everybody. And take care and have a wonderful day or night, whatever.
Wherever.
Thank you, everybody.
Thank you, Mark. This was great. This was definitely one of my favorites. Talk to